equations of linear motion. Now, in order for us to be able to express mathematical concepts with regard to linear motion, and these equations are very important because they help us to understand mathematical concepts related to this topic and to also explain some of the concepts with regard to linear motion. Okay, so it is important for you to understand these equations, and that is why I want to take the initiative of trying to lead us into understanding how motion is simply the change of velocity. It is defined as the change of velocity with respect to time. It is the change of velocity with respect to time. So the change of velocity will obviously be expressed in meters per second, and the time is in seconds, which means the SI unit of acceleration is what? Meters per square second. Yeah. So acceleration is expressed in meters per square second because you are finding the ratio of velocity with time. Okay. Now, acceleration is equal to change in velocity. Change in velocity means you have different velocities for a moving object. So it could be varying in velocity, or it could be moving from a point of rest, or it could be coming to rest. So change in velocity can be taken as the difference between final velocity and initial velocity with respect to time. So always remember these points. V represents initial velocity, final velocity. U represents initial, and T represents the time interval between or take for acceleration, and T for time. Okay. Number two, we shall look at the second one, and here we are going to use displacement. Okay? Displacement of an object. So remember we said displacement is what? It is the shortest distance covered by a moving object in a specific what? Direction. So you must have the effect or the effect of direction. Now, if velocity is equal to displacement, change in displacement per unit time, so that means displacement will be equal to what? Will be equal to velocity times time. Sindio? Yeah, because velocity is displacement divided by time, and therefore displacement will be velocity multiplied by time. But if we have an object that is experiencing a change in velocity, we must take the average velocity. Utapata kama ni gari tunaenda na 20 kilometers per hour, ikifika mahali it is 30, ikifika mahali it is 50, and so on. So you realize you are having a change in velocity. And if you are dealing with such an object, you cannot make up your mind to either use 20, 30, or 50. So what do? You look for the average velocity. Yeah. So you are dealing with the average velocity. Now, displacement, letter S stands for displacement. Average velocity will be initial velocity plus final velocity divided by what? 2. So you take initial velocity, add the final velocity, and find the average of those two, and then this one is multiplied by what? By time, huh? Yeah. So it means displacement is equal to u plus v divided by 2 brackets multiplied by the time interval involved in calculation of that displacement. So again, we revert to some mathematics, and we shall start by substituting v here. In the first equation, we found out that v is equal to u plus at. So that means here we shall have, instead of v, tutaandika u plus at. So it's just a simple substitution of final velocity with its equivalent from the first equation. So that's what we have, u plus at divided by 2 times t. Then basically what we want to do is find out if you have like terms and collect them. Sindio? What are the like terms? U squared. 2u. U plus u is 2u plus at divided by 2, and then you multiply that by t. Okay, so we continue. We are not there yet. Okay, so what should we do next from that step? We open the brackets, huh? Okay, let's open up the brackets. So that means S will be what? 2ut. Okay, 2ut plus 80 squared. T will be squared because you have 80 times t there, and then over 2, huh? And then over 2. Okay. Next, we can multiply by 2, huh? We can multiply by 2. We can multiply by 2. So that means we have 2s is equal to 2ut plus 80 squared. Then you can divide by 2 all through, so that you have your s being equal to ut plus a half 80 squared. Okay, that will be the second equation of linear motion. S is equal to ut plus 80 squared over 2. So the first one gives you the value of v, and the second one gives you the value of s in terms of u, a, and t. Let's look at the third equation. There's 3 of them. So for the third, again, you begin with displacement. Huh? You begin with displacement. Displacement is equal to average velocity times time, and that led us to s is equal to u plus v over 2 times t. Times t. Remember, there's a question multiplied by t, which is in fact v minus u over a. Okay, so we are having u plus v over 2 times v minus u divided by a, and that is a product. As you can see, we have 2 brackets that we need to open up and see what we get there. So let's open up the brackets. That is expansion. Expansion. Okay. So we can start by expanding the numerator. That means s will be what? U times v. Is that so?
No.
This is what you do, huh? U, v minus u,
v
plus v into v minus U divided by what? 2 times A. 2 times A. That means S will be UV minus U squared plus V squared minus UV. Okay? Minus UV divided by 2A. I think you can see that this UV will cancel with the other one, and therefore S remains negative U squared plus V squared divided by 2A. Okay? Not there yet. Not there yet. We should make V the subject of the formula. Okay? So times 2A, times 2A on both sides, times 2A. So this one disappears, and the left hand side becomes 2AS is equal to negative U squared plus V squared, which can be expressed as V squared minus U squared. Yes. So that means V squared is equal to U squared plus 2AS. That will be the third equation of linear motion. V squared is equal to U squared plus 2AS. Circumstances. You are dealing with. So what will be 50 meters per second? Initial velocity, because the question says a body moving initially at 50 meters per second. So you want to note that the initial velocity is 50 meters per second. Decelerates uniformly at 2 meters per square second. Decelerates uniformly at 2 meters per square second. What do we get from there? What do we get from there? A. Have you seen any equation that has deceleration? So what is the meaning of deceleration? Negative acceleration. You get the point? So if you come across deceleration in a equation, you represent it as a negative acceleration, and in this case we are talking about 2 meters per square second. So do not write deceleration there, because no equation will give you an allowance for using deceleration until it comes to rest. What information do we get from there? U is 50. It comes to rest, so it means its final velocity is 0. It's not moving because it has attained 0 velocity. What distance does it cover from the time it started to accelerate? What distance does it cover from the time it began to accelerate? So that means the missing quantity is what? Speed. Distance. What distance or displacement, in this case squared plus 2AS. Okay? So what follows is just substitution. You replace V is equal to 0 and U is equal to 50. Okay? And A is equal to negative 2. That is acceleration. And then you are looking for S. You are looking for S. So that means 0 is equal to what? 2500 plus negative 4S. Because 2 times negative 2 will be negative 4. So when you bring negative 4S on this other side, this is what you will obtain. Divide 4 on both sides and you will have your S as what? What do you get for that? 625 meters. So it means the object traveled a total distance of 625 meters during that period. During that